This one is for least common multiple, and it's going to be in rationals. So if you want to go to your rationals section of your notebook, these are all least common multiple problems. You've been working so far on greatest common factor because y'all all have been doing a lot of factoring. So when you get to this one, some students were getting a little confused on what they were supposed to do. So let me show you one of the problems. Our first example, I'm going to do find, and I'm just going to write LCM. Find the least common multiple, and my two terms are 4w to the 6th, u to the 4th, and my second one is 15v to the 7th, w to the 2nd, u to the 8th. So my expressions again are 4w to the 6th, u to the 4th, and 15 u to the 7th, w to the 2nd, and v to the 8th. Okay, so I want to find the least common multiple. Couple of things that you need to remember for least common multiple. Multiples, those are your, like the multiples of 5, 10, 15, 20, 25, 30, 35, 40. Your multiples are going to be bigger. So it's not breaking down the numbers this time. It's thinking about those numbers being multiplied. So I'm looking at my numerical part. I've got a 4 and I've got a 15. So instead of thinking about, like in greatest common factor, what goes into 4 and 15, I'm thinking about what 4 and 15 go into. So I have to think about all the multiples of 4. The multiples of 4 are 4 and 8 and then 12 and so on. The multiples of 15 are 15, then the next one would be 30, then the next one would be 45 and so on. Okay? To me, the easiest way to find the least common multiple with the numbers is to take the biggest number and use that number and get his multiples and then find one that the little number goes into. Okay? So my first one would be 15, my second one would be 30, my next one would be 45. 4 doesn't go into any of those, okay? Then what would be after 45? 60, that's right, 60. Okay, I'm going to stop there because I think 4 goes into 60, okay? So if I think about all the things that multiply together to make 60, 4 times 15 does. So for my numerical part, my least common multiple is going to be 60. That's the easy part, really. Actually, that's the harder part. The easy part's the variables. So my least common multiple, I'm going to need a 60. And now let's get our variables. Okay, so this is going to be weird, and I'm going to say this, and I'm going to write it down. And when I taught my daughter how to do this, she was like, Mom, that is crazy. And so she told her math teacher. Her math teacher said, that's the craziest thing I've ever heard. And so I told my daughter, who cares? It works, okay? So whenever you're doing least common multiple, this is the phrase that I want you to think in your head. This is not greatest common factor, okay? This is least common multiple. You're looking for a common denominator. That's what you're trying to find, a common denominator. Okay, you need... This is for the variables. I'm going to write variables right here. So for the variables, this is my little phrase that I told my daughter. I said, you need sum of everybody. Okay? Sum of everybody. That means that every factor that you see that's part of the original problem, you have to have that base. Every base that you see, you're going to need the base. And then at the same time, you need the most of anybody. Okay? I want some of everybody, but the most of anybody. That's my little phrase. Some of everybody, but the most of anybody. Some of everybody, but the most of anybody. So I'm looking at now all the variables that I have. So what are all the bases that I see in my original two expressions? I see a W. What else do you see? A U. What else do you see?
That's it.
No, look down here. Look down here. What else do you see? A V. Okay, I have a W. They both have W's, right? Okay, I have a U. They both had U's. And then I had a V. So that's sum of everybody. I need a W, a U, and a V. I need every base that I see. Go ahead, babe.
Wait, but there's not a V on the other side.
I know, and that's the confusing part. So that's why I explained it to my daughter. I was like, okay, you just have to do my craziness. Just do my craziness. Sum of everybody. So you want sum of every base that you see. It doesn't have to be in both. Every base that you see. So I see a U, I see a V, and I see a W. All right? Okay. So now, once I get sum of everybody, I've got sum of everybody. Now I go back and I want what? The most of anybody. So I go back to the W and I look at the W's. I had a W to the 6th and I had a W to the 2nd. Which one is the most? W to the 6th. So that means I need a power of 6. Okay, check the U's. I have a U to the 4th and a U to the 7th. So how much U do I want? U to the 7th. And then check the V. I only had one V. V to the what? 8th. He's the most I had. He's the only thing I had. So V to the 8th. And that is your common denominator. So your common denominator would be 60, W to the 6th, U to the 7th, V to the 8th.
So you just take a little bit of everything from both sides.
That's right. You take everything. Okay?
It's a little weird, but
It is weird. But what is going to happen, this section is going to move on into adding fractions. And so you have to be able to find a common denominator in order to add the
what's
fractions.
the proper way of doing this?
That, you don't think that's proper, Jorge? I don't
I want to
understand.
see the difference and
What-
everything.
What do you mean?
Like, I want to see the difference and everything from what you know and then what the original is.
Okay, when you go back and look at the explanation, it doesn't explain it like that. Daisy's on it right now. What did it say to you? It says crazy stuff, like things that you can't really. It talks about how when you're looking for least common multiple, you are looking for something that your original expressions can go into. Okay, so you're thinking of it as a multiplier. So the question is, could I take, because this is eventually, Jorge, what you're going to have to do, okay? The question is, could I take 4, let's say this was a fraction, 1 over 4w to the 6, u to the 4th. Could I take that and rewrite it so that it had 60 w to the 6th, u to the 7th, v to the 8th? That's what you're eventually going to be doing. So can I do that? Is that possible? Yes. It's a multiple with multiplication. So if this is going to be my common denominator, what would I multiply by to make this happen? And that's where you're going after this section. Okay, so what would I multiply by in order to make that happen? Well, let's look at it. I would need a 4 times a 15, okay? That would give me the 60. And then I have a w to the 6 and a w to the 6. I don't need any more w's. I have enough. I have a u to the 4th, but I'm supposed to have a what? U to the 7th. I'm short some u's, right? So I would need a u to the 3rd. And I don't have any v's to start off with, but I ended up with a v to the 8th. So that means I had to multiply by v to the 8th. So that would be my multiplier. And so whatever I do to the denominator of a fraction, I have to do to the numerator of the fraction. And so I'd multiply those, and my new fraction would be this. These are polynomial fractions, little different than regular fractions, but it's the same thing. Okay, so that's where we're going. So when you read the explanation,
See it and everything.
yes,
Kinda
when
like the what is it? When you cross multiply the x's and everything.
Yes.
Or I do my funny little square.
yes,
Yeah, that's.
you like to be able to
sometimes-
see it.
Yeah.
Yes. Okay, so that's where we're going right there.
Okay.
Okay,